Very good morning, class. Today we are going to start with the physical properties of haloalkanes, and later on in the same video we will understand about the chirality and optical isomerism of the haloalkane. So that part is going to be very interesting and very important also. So watch the video and let's start with the video. So physical properties we will do in the quick way. Boiling point means as the molecular mass increases, boiling point increases, and the branching increases, boiling point decreases. We know that boiling point depend upon the surface area. That means van der Waals force of attraction. More the force of attraction, more the surface area, more the force of attraction, and hence the boiling point will be more. But when we move to branch, when we make it as a branch, the surface area decreases, and hence the van der Waals force of attraction decreases, and that's why boiling point decreases. All the aryl halides are heavier than water. This is the point to learn, and that's why they sink, or they sink in the water. Boiling point of haloalkanes is always higher than mass of its corresponding hydrocarbon. Obviously, because of halogen will be there and hydrocarbon. If we are talking about the hydrocarbon, it is only carbon and hydrogen. But if we are talking about the haloalkanes, it is going to be added with the halogen also. So obviously, more van der Waals force of attraction will be there, and hence the boiling point will be high. For the same alkyl, that Ri will be higher boiling point than Rbr, then RCl, and then the Rf. The same reason is that some students get confused in this boiling point. They think that they need energy to break this bond. See, this boiling point is not the energy, is not the temperature required to break this Ri bond. Okay, the boiling point is the temperature by which this Ri can be vaporized as a whole Ri. Got it? So yeah, Ri molecules we have to check the force of attraction between Ri and Ri. Got it? समझ में आई बात? It's not to require that energy required to break this Ri bond. Chalo, let's do. Boiling point of haloarenes are equivalent to the boiling point of corresponding haloarenes. It should be haloalkanes. Okay, let me correct it. Haloalkanes. Okay. Haloalkenes. Alkenes. So it will be. Okay. Boiling point of dihalobenzene are nearly same, but melting point differ. Halobenzene का मतलब ortho, meta, and para we are talking about. So their boiling point are nearly same, but their melting point differs because the para dihalobenzene जो होता that is good for, it fits into the crystal, and that's why its melting point is like quite different from the other ortho and para, ortho and meta. Okay, so this is the experimental factor. We have to know that melting point, if you check the boiling point, if you check, it is almost same, 453, 446, 448. It's not that much different. But melting point, if you check, the para will have the more melting point because it fits into the crystal. So its melting will be difficult. Okay, so that's why it is having more melting point. So sometimes the question can be asked that why out of these three, which one has more melting point? So this is boiling point, it will never be asked for this, but melting point it can be asked, and melting point is high because of this fit into the crystals. Okay, chali. So next properties, density, bromo, iodo, polychloro derivatives of hydrocarbon are heavier than water. That means they sink in the water. The density increases with increase in number of carbon. As the number of carbon increases, obviously mass increases, density increases, and volume at halogen atoms and the atomic mass of the hydrogen atom also. Solubility, if I talk about, although they are polar, haloalkanes, although they are polar, but they are not completely soluble in water because they don't have the tendency to form the hydrogen bond. The haloalkanes are very slightly soluble in water. So question can be asked that although the haloalkanes are polar in nature, but they are not soluble in the polar solvent like water. So the reason is that because they are unable to make the hydrogen bond, because hydrogen bond is formed only between hydrogen of the one molecule and FON, not other halogens. Got it? So, okay. However, haloalkanes tend to dissolve in organic solvent because the new intermolecular attraction between haloalkanes and the solvent molecules have much the same strength as the ones being broken in the separate haloalkanes and solvent molecules. Or it is going to be very simple to say that the non-polar, because that haloalkanes being like what we say, if they are not soluble in this, so they will be soluble in the organic solvent. Okay, and the reason is that almost they have same strength, same force of attraction between that. Okay, chali next this is going to be next important topic, and that is optically active compounds. So in this, before starting this, before going deep into that, we have to understand few things, and that is that what is the optically activity. So this is already I have explained about you in that my previous video, that light are moving in all direction. When it is passed through the Nicol prism, it becomes monochromatic. That means either it will move in a one direction, it will move in a one direction only. Okay, and whenever it is passed through any optically active compound, it either rotates this PPL. This is called PPL, plane polarized light. Okay, so when this light move in a Nicol prism, it convert into monochromatic light, and that is PPL. And if it is passing through any optically active compound, so what will happen? This will either move in the right direction or in the left direction. I have written over here. It's a like it's called as, here it is moving now. This one it is moving, so it should be, sorry, it should be left direction. I will write it over correct. I will make it correct, and this is right direction. Okay, right means clockwise and left means anti-clockwise we will consider. Okay, so the one which is moving in the hence it will also be reversed. The one which is moving in the left direction will be called levo. This is levo, or anti-clockwise we can say that levo, and the one which is moving in the right direction will be considered as dextro, that means clockwise. Hope it is clear. Yes, and if that light is not going to rotate in any fixed direction, then this substance will be called optically inactive substance. Okay, so there is no rotation, as it is we get. So that means the compound, this compound, whatever the compound we have through which we have passed this PPL, that is called optically inactive. Got it? Okay, so now the compound which can rotate the plane polarized light are known as optically active compound, that I have told you. Dextrorotatory compounds and levorotatory compounds are optical isomers. And this phenomenon of getting the rotation, different rotation, that is called optical isomerism. And these two are, that left and dextro and levo are called optical isomers. Okay, but this is all about the practical knowledge, how we will do in the theory. Like if it is given in your question, how you will solve. Okay, and very important part of this is, so many questions like can be asked, and it has been asked. Okay, so let's start with this one by one. First of all, we will know about the, to give the theoretical knowledge, that theoretically we will say to dextro or levo, we have to know chirality. So one more thing I just want to tell you, that dextro and levo, whenever we talk about now, this is completely optically active. Okay, so experimentally determined, and it is not possible to find it. So dextro can be written as a D and levo is written as a L. But whenever we talk about the theoretical, like we will do in our class, in our questions form, so then dextro will be named as R rectus and levo will be named as sinister. Okay, it won't be, we will not name it as a D and L, because D and L is completely experimental. Got it? So in theoretical we will do R and S. So let's do with this. First of all, we will know about the chirality. Chirality का मतलब क्या होता है? Asymmetric carbon. Asymmetric carbon, that means such sp3 hybridized carbon which is attached with the 4 different substituents is known as chiral carbon. Got it? That means if the sp3 hybridized carbon is attached with the 4 different substituents is known as chiral carbon. Got it? Okay, so this is asymmetric carbon. I have told you about this. Okay, that means all the 4 different groups should be attached. Like example, can this be a chiral center? It can't be because it is having sp2 hybridized. Yes, this carbon is sp2 hybridized. The first criteria is that it should be sp3 hybridized. Okay, so if we talk about this carbon, it is at one side it is this CH2OH, another side it is OH, third side it is H, and fourth side it is this much group. So yes, this is a chiral center. Got it? This is the chiral center too. And if you talk about this, this is also a chiral center because we can see one side this much is group, another side this group is there, third side H is there, and fourth side this one is there. Isn't it? Two chiral center. In this also you can say this one is not the chiral center because both are same group. Okay. Can it be a chiral center? It can be because it can't be because both are hydrogen here also, here also, here also. So these are the chiral center. I hope it is clear. Yes, chiral center, that means we have to find that the carbon should be attached with the 4 different groups anyway. Okay. Now this is molecule 1 and molecule 2. See, if I'm talking about this center, this all is chiral. Okay. Wedge, this is called wedge and this is called dash. Dash is towards you and wedge is away from you. Got it? Okay. So if I'm drawing the mirror image of this, we are getting this Br will be this side and this F will come on this side. Clear? Got it? The mirror image, that पूरा part जो है वो reverse हो जाएगा and this F. So here the three things we will know that chiral. First of all is chiral. Chirals, that means the object which are non-superimposable on their mirror image. What does it mean? समझ में आया? इसका मतलब कि that non-superimposable होना चाहिए. If you just take it and keep it on this, are they going to superimpose? No. So that condition is called non-superimposable. Okay. If the mirror images are non-superimposable, then it is called a chiral compound. Clear? समझ में आई बात? Okay. Now next, enantiomers. Enantiomers I will explain properly. Stereoisomers with non-superimposable mirror image, that is called enantiomer. That means we can say molecule 1 and molecule 2 are enantiomers because they are the same compound, but they are non-superimposable mirror image of each other. So that's why we can say that molecule 1 and molecule 2 are enantiomer of each other. Got it? Any problem? And next concept is diastereomers. Diastereomers are the compound which are not mirror image of each other. Or you can say that in the diastereomers, at least 2 chiral center will be there and one part, upper part or lower part. One part will be superimposable and another part will not be imposable, like this. So in that case, it is a diastereomers. Few example will be there, so that I will explain through that. Okay. So now let's move to next slide after this. That is meso compounds. Okay. And how they are stereochemical relationship. What are the stereochemical relationship? But before knowing this meso compound, we have to know few factors like enantiomers, diastereomers, and all this. So let's move to this. And here it is written as RS, something like that. So that don't be confused. We will be discussing this in the later slide. Okay. So for this slide only, for the instant, you should know this like. This is the compound, and if I'm taking a compound as an example, and I'm going to take a mirror image of this. So this is the mirror image I will get. So just take it out and keep it on this. Is it going to impose? No, it's not going to impose. So it is mirror image, not superimposable each other. So such mirror images, though who are not superimposable to each other, they are called enantiomers. Clear? So this 1 and 2 structure is enantiomers of each other. Let me write over here. 1 and 2, they are the enantiomer of each other. Got it? Okay. Now if I'm taking this example only, and what I am doing, I am keeping the lower part fixed and just rotating the upper part. Okay. Just rotating the upper part. So what I'm going to get now, just take it out and put it on this. Is it going to superimpose each other? No. But yes also. Why? Like half part, the lower part is going to impose each other, but the upper part will not impose each other. Yes. So if such cases are there that one half of that compound will impose each other while the another half will not, then this case is called diastereomers. So first and third are diastereomers of each other. Got it? Clear? Okay, just compare this third structure with the second structure. In this case also you can see that the lower part is not superimposable with each other, but the upper half is imposable, isn't it? So that means in this case also the one part is imposable and another part is not imposable. So then second and third will also be diastereomers. So this represents that blue one, these two are diastereomers, these two are diastereomers, and if we are talking about this is enantiomers. Now, what is a meso compound? For the definition, I'm going to tell you here that if the equal amount of R and S are present in a same compound, okay, just listen this factor, equal amount of R and S, that means equal amount of clockwise and anti-clockwise rotation is possible in a same compound, got it? This is the point. So then it becomes optically inactive due to the internal compensation. Three things you have to learn in this point: equal amount of dextro and levo rotation, that means clockwise and anti-clockwise rotation should be there in the same compound, and what they are going to nullify each other's effect, and that's why that compound will be optically inactive. So these 3 points: optically inactive, internal compensation, and equal amount of rotation. So that is called meso compound. Now you might be wondering that what is this that rotation. So that, as I told you, that we will be discussing this in later slide. Okay, and if I'm doing this, I'm taking the mirror image of this. So this is the mirror image I will get. Yes. So these two will be enantiomers, that can be, but we will not say this is the third compound and this is the fourth compound are the meso compound. We will not say that these two are the meso. Okay, why? Because if we will we are just 180 degree, if we are rotating, we are getting the same compound. That means that same S and R will be there, equal amount of this, the same compound, that and it is mirror image as well. And if we are going to rotate this 180 degree by this, so we will get the same compound. That means the meso compound, if I'm talking about, only one is the meso compound, that is the third, not the fourth. Got it? Because these two are the same compound, so we will not repeat again. Yes, of course, they are the enantiomer of each other, as I have told you that they are the mirror image. Okay, so that's why they are the mirror image, and that's why they are enantiomers, but not the meso compound. We can say, oh, how many meso compounds over here? So you will say only one. And how many diastereomers compound set are there? So that will be two set. What are that set? That this and this, first and third, and next is second and third. And what are the enantiomer set? First and second, third and fourth. So two sets. I hope it is clear. So next, move to next slide. Okay, so now how to check the chirality of the molecule? How we check? Okay, so for this, the few things we are now supposed to know. That is, one is called plane of symmetry, POS. It should not be there. If it is there, that molecule will not be chiral, and that means it will not be optically active. So plane of symmetry should be absent. Center of symmetry should also be absent. Okay, axis of symmetry, that should also be absent, but it's not so necessary to consider for the chirality. Okay, and another is alternative axis of symmetry. That means this should also be absent, but agar hame COS and POS if we are getting, then AOS will be present. अपने आप ये होगा, alternative axis of symmetry will be there. So we have to know the two things, that is plane of symmetry and the center of symmetry. That two things should be absent. Yes, then only it will be what? Chiral. Otherwise it won't be a chiral, and if not chiral, it will be optically inactive. So what is this plane of symmetry? For plane of symmetry, a plane dividing compound, a plane, that means which is going to divide the compound into two equal half having mirror image kind relationship. Like if I'm going to isko cut karungi, if I'm going to cut in this way, is it dividing into two equal parts? Yes. Is it the mirror image of each other? Tell me. Yes, they are like this. Got it? So that means here the plane of symmetry is present. Here POS is present. Okay, we will write POS is present. So that means it will not show the chirality. In this case, if we check that, and we are going to divide this molecule with by any plane, you divide it in this way, you divide it in this way, any plane. Is this same? Are they mirror image of each other? Are they equal parts? No. One in this case, this is the dash. That means it is towards you. And this one is away you. Yes. So they are not in the same plane, and that's why their POS is not present over here. So it will show the chirality and it can be optically active. Got it? Another molecule is this. This is the molecule. Check whether the POS is there or not. See, if you are going to divide this by this way, is this there? Is there any symmetry? Yes, bilkul symmetry is there. See, this and this one is the mirror image. Here also, it's quite clear that Me will be there, carbon is there, so methyl will be there. So quite clear. So these two are exactly mirror image of each other, isn't it? And that means it is POS. It is having POS, so the molecule will not show the chirality, and that means optically inactive it will be. हमें POS को absent करना है. That means this is the only compound which is going to show the chirality. Okay. Now another, a plane dividing compound into two equal half is half having mirror image kind relationship. Same thing. Let's do some example or more example. In this way, if I'm going to divide, so this is called molecular symmetry. पूरे molecule की symmetry. Okay. So this is the molecular plane, and I'm going to divide in this way. So we are going to get the two equal half, and that means it is again not chiral. Next, few more example, like see, this is the example tetrahedral structure, methane, and I'm going to cut with this plane. This one is the plane, okay, you can see. So we are getting the two equal parts, isn't it? Just check once again. This is the plane and these two equal parts we are getting. So it is having POS. So that means it will not show the chirality. In this case also, this is, although this is bromomethane, but with this plane, we can see that we are getting two equal parts. Yes, other planes are not there. But in this case, only one plane is there, and due to which we are getting the plane of symmetry. Here also we can see this is that dibromomethane. If we are checking this plane, we are getting the same molecules, isn't it? So all three have POS. Here in all three cases, POS is there. That means it is not going to show the chirality. Clear, Victor? Clear? All three have. Here also. And here also. That means all three will not show the chirality, and that means optically inactive. Okay. Chali. Next, few more example. If we are talking about this. So this is no side. In any side, we are not going to get the plane of symmetry, isn't it? All the four are different. So we'll not get. That means it is a chiral. It can show the optically active compound. Got it? Plane of symmetry is not there. So that means it is a chiral, and hence it will show the optically active. What about this? If I'm going to cut with this, ye dekho, this is the plane cutting with this. Ye as a vertically I'm cutting. So I'm getting the same equal size, isn't it? Equal things we are getting. This way, vertically I'm going to cut. Okay, dear? So in this case, the POS is there. The POS is there, and hence it won't show the optical activity. Got it? Okay, so now center of symmetry. Center of symmetry, that means there is an imaginary point from where in all direction, if we move, any direction if we move, opposite, we are going to move in opposite direction. Then at the same distance, we will find the same group, then there will be center of symmetry. And if opposite direction, if we are going to get the same group, then there will be center of symmetry. And if it is not, then there will be no center of symmetry. So let's do with this example. In this is the imaginary point. If I'm going in opposite direction, I'm going in this. So front, I'm going to get the chlorine, and in this way, back side, if I'm going opposite direction. If I'm going in front side, I'm getting chlorine, and if I'm going back side, I'm getting hydrogen. So this is two different groups I'm getting. So that means, is there any center of symmetry? No, there is no center of symmetry. Got it? So opposite direction, different groups are present, so there is no center of symmetry. Got it? Okay, another example. Just take that imaginary line over here, imaginary point over here, and go in opposite direction. If you are going in this way, I'm going to get methyl. Here, opposite direction, I'm going to methyl, get methyl. In this way, hydrogen. So is there center of symmetry? In all the direction, opposite अगर हम move करते हैं, we are getting the same way. Yes, same compound. So that means yes, there is a center of symmetry. So that means this molecule will not show chirality and hence the compound will be optically inactive. चलिए. So this green means yes, US is there. Now in this case, अगर हम यहाँ पे देखते हैं, so is there any center of symmetry, plane of symmetry? तो बिल्कुल नहीं है, कहीं से भी नहीं है. ठीक है, got it? If I'm talking about center of symmetry, so see in all direction I'm going to get. Am I going to get the same compound? Yeah, same molecule. This way the carbon is there, but this way no carbon is there. Here it is, see methyl is there, but in this way nothing is there. Got it? So in this way I'm going to get the carbon, but in this way nothing to get. So center of symmetry is also again not there. So this and this compound can show the optically activeness, but this compound, because it is having COS, so it will not show the optically activity. Now note, we have to check what chirality. We have to check only POS and COS. That is more than enough for the chirality. Okay, if any of them is present, then the molecule is achiral. If it is not like that, we have to find both the POS and both the COS and POS. Any one of them. If plane of symmetry is also there or COS is there, कोई भी एक चीज अगर है वहाँ पे present, the molecule will be achiral and it will not show the optically activeness. But if both absent, then molecule is chiral. Got it? अगर दोनों absent है, POS भी नहीं होना चाहिए, COS भी नहीं होना चाहिए, then only the molecule will be chiral. Otherwise, इन दोनों में से अगर कोई भी एक है, तो molecule will be achiral and it will not show the optically activity. Got it? This is the example. One example we can say that hand. I'm going to keep show my hand and that the mirror image. This is not going to overlap. This is not going to impose exactly. Just take it this, utha ke, and then keep it on this. So this hydrogen cannot impose this group, these three. Yes. So that means it is non-superimposable mirror image, and that's why they are called. They can be called optically active compounds, isomers, and they are enantiomer of each other. Just move to a few more examples. So see, this is bromochlorofluoromethane. If I'm going to draw the structure, I will get like this. And mirror image, if I'm getting this two will come over there. Here is bromine is in the dash and chlorine is in the wedge. Okay, this chlorine is towards you and bromine is away you. So if I'm going to take the mirror image like this, and if I will rotate this mirror image by 180 degree, so we will get this. But what will happen? See, earlier the bromine was in the dash. That means bromine was away from you. But in this case, when we will rotate it by 180 degree, the chlorine will away from you and bromine will come closer to each other. So now try to impose this one, try to impose on this. Is it going to impose each other? No, because one is, देखो यहाँ पे bromine is in the backside and here the chlorine is backside. So this one is not going to impose this mirror image, and that's why they too will be called enantiomers. ये enantiomers कह सकते हैं. We can say that they are the mirror image and not superimposable, so they are enantiomer. Got it? In this case, let's see. The chlorine is wedge and dash also. Okay, wedge and dash also. So if I'm going to take the mirror image, this chlorine will come over here. But यहाँ पे if I will rotate this by 180 degree, both are the chlorine. So they are the mirror image of each other. But what? It is going to impose, isn't it? This if I'm going to rotate this, so this is going to rotate impose on that, and that's why they too are not called enantiomers. Got it, bache? So that means simply mirror image will not be called like enantiomers. What we have to check? We have to check one more thing, that this whatever the mirror image we are getting, उस mirror image को we have to rotate by 180 degree and then we have to check कि whether it is going to impose or not. First तो ये भी check करेंगे and दूसरा 180 degree rotate करके भी check करेंगे. If in the both case it is not going to impose each other, then only it will be called enantiomers like this. Got it? Here it is going to impose, so that means can be superimposed. So these two will not be called Yes, of course they are mirror image, but they are not the enantiomers. Got it, dear? Okay. Now optical active compounds. So this is RNS, as I have already told you that dextro and levo is the experimental value we cannot find. So what we are supposed to find? We will find it in the RNS way. So first of all, let's do with some definition part. That is the racemic mixture. If in the same compound, a mixture containing there are the two things. One is racemic mixture and another is meso compound. I will explain meso already. We have done a few hints we have done. Okay, introduction we have done. So a mixture containing two enantiomers in equal proportion. A mixture containing two enantiomers in equal proportion. That means one should be D and another should be L in equal proportion. Then it will be represented by DL or plus minus, and this will be called the racemic mixture, and the process is known as racemation. We can say that here they cancel each other's optically activeness due to external compensation. Got it? यहाँ पे एक important point होता है, that is external compensation. But when we talk about the meso compound, in the meso compound, the upper half and the lower half, they cancel each other optical activeness, and that's why they are also what we say optically inactive. They can also be optically inactive, but they are optically inactive due to internal compensation, and racemic mixture is optically inactive due to external compensation. I hope it is clear. Yes. So see, this is the compound. One is there, and two is in the like wedge way. Sorry, dash way, and three is in the wedge way. Okay, that means three is towards you, and two is behind you, away from you, and this is the leaving group L. So if the nucleophile is attacking, this can attack from the both side, attack from the front side, as well as attack from the back side. If it is attacking from the front side, this L will move and NU will attach. That means the configuration is going to retain. Configuration 1 yahan tha, it is like this, 2 was there, 2 is there, and 3 was at the towards you, 3 is towards you. So this structure is going to continue retain. So that's why this is known as retention. But if the nucleophile attacks from the back side, okay, then what will happen? This 2 is jo yahan dekho, this 2 was jo that is going to invert. The nucleophile will come over here and the 2 is coming like this. Yes, the structure get exactly inverted, and that is called inversion, and this was given by Walden inversion. Got it? समझ में आई बात? So inversion हो जाता है, यानी retention, this and this both are there. If A and B equally combine हो जाए, in equal amount में conversion combine हो जाए, then this will be called racemate or indefinite mixture. That means racemic mixture. Got it? समझ में आ गई बात? Retained compound and the inverted compound, yani one is D, another is L. If they combine with each other in the equal proportion, they will give you the racemic mixture, and that they will be optically inactive due to the external compensation. I hope it is clear. Yes. Chani. Now let's move to this RNS configuration, which is important part. So few rules we are supposed to learn, that is atom of higher atomic number gets priority. That is quite clear, आपको पता होगा. Yes, atom of higher priority is assigned number 1 and atom of least priority is assigned number 4. Yeah, this is the point, and 2, 3 we will decide in between. We will go one by one. So decreasing priority, this is I because of more molecular mass, more atomic number. So that's why it will get the more priority, and then how it is decreasing. As the molecular mass, as the atomic number decreases, atomic mass decreases, we can say that priority is also going to decrease. If the first atom of the two group have the same atomic number, yes, then the relative priority of the group is decided by the comparison of the atomic number of the next atom. Like in this case, out of this, if it is attached, one side it is attached with a CS3 and another and C2H5. One side it is attached with this. So out of these two, which will get priority? This is also carbon, here also carbon. But if we check the second atom, we are going to get the hydrogen. But if we are going to check the second atom, we are going to carbon. Carbon has more molecular mass or more atomic mass, sorry. So that's why ethyl group will get the more priority than the methyl group. In both, first atom is carbon, but next atom is in CH3 is H, while in CH2 CH3 next atom is C. So ethyl group will get is given higher priority than the methyl group. Got it? This plays very important role. So you should know this thing. Okay. So now another thing, CHO is given. These are the some rules you can say. CHO is given higher priority than the CN. Why so? CH double bond C is directly attached to the oxygen. Okay, but in this case, if you talk about the second atom, it is nitrogen. So oxygen will get more priority than the nitrogen. That's why CHO will get more priority than the CN. Clear? Multiple bonds are treated as separate single bond. That means जितना ज़्यादा number of multiple bonds होंगे, we will consider it more prior. Got it? Like अगर एक side में it is CH2 attached and another side it is CH triple bond CH attached. So which will get more priority? CH triple bond CH will get more priority. Got it बच्चे? समझ में आई बात? It means this. मल्टीपल बॉन्ड्स आर ट्रीटेड एज सेपरेट सिंगल बॉन्ड. इसका मतलब यही है दैट जितने ज्यादा मल्टीपल बॉन्ड होंगे वो सिंगल बॉन्ड कंसीडर होंगे, मतलब उसको आप सिंगल कार्बन कंसीडर करोगे एंड मोर मॉलिक्यूलर मास हो जाएगा, सो इट विल गेट मोर प्रायोरिटी. CH double bond is given priority over CH2OH. Like double bond is there, so we will consider that one single bond, and that means it is going to attach with we have to assume that it is single bond say carbon attached है, तो दो carbon हो गए, and that's why this will get the more priority than this. Got it? A simple way, multiple bond will be treated as will be given as more priority than the single bond. That's it. Okay. In this case, if you check this, iodine will have more priority, bromine, chlorine, oxygen, then nitrogen, and then NH2. This is because of the first atom having more atomic number. Yes, got it here? So this is nowhere related with the functional group. This is simply it as considered as the number of, like what we say, atomic number. Okay. When priority of groups are decided by sequence rule, then figure is viewed from the group of higher priority to the lower priority. That means we have to move from 1 to 3. Okay. And move your eye. If eye moves in clockwise direction, then the configuration is R, that is called rectus. And if eye moves in anti-clockwise direction, then the configuration is S, sinister. Okay. And if the least one which is like named as a fourth, okay, is at horizontal, okay, then the rotation will be reversed. Agar horizontal pe hai least, to reverse kar denge hum rotation ko. Like if it is coming R, if it is clockwise, so should be R, but it would be S. समझ में आ गई बात? Let's do with the some example. So in this case, it is see here, this hydrogen is the least one for sure, quite clear. First atom is oxygen, first atom is carbon, first atom is carbon. So obviously this will get the priority 1. And this is carbon. Second atom, you have to check this hydrogen. I told double bond O, yes, and here it is single bond. So I have told you that multiple bond will get more priority over this. So that means 2 and 3. So just rotate this 1, 2, 3 you go, and it is coming as a clockwise. And clockwise, so it should be R, and it will be R. Why? Because the least one is at the vertical line. Okay, agar horizontal pe aayega, then only we will reverse. Agar vertical pe aata, to as it is. Got it? In this case, if you check 1, 2, 3, this is anti-clockwise. That means it is going to be S. It will be S. Yes. Chali, few questions already I have numbered, so it make your work easy. Let's do with this. This is 1, 2, 3. So that means we are going to move in clockwise direction, isn't it? And if I'm going to move in clockwise direction, it should be R. So, but it will be what? Hydrogen is at the horizontal. Should be R, but it will be S. Clear? In this case, 1, 2, 3. We don't have to consider the 4. Just simply 1, 2, 3. Check it. So 1, 2, 3 is anti-clockwise, but H is on the horizontal. So should be S, but it will be R. Clear? Now in this case, 1, 2, 3. So anti-clockwise should be S, but will be R. Clear? In this case, 1, 2, 3. So clockwise should be R, but will be S because of H. Got it? I hope it is clear. Chaliye. Now a few more questions. Which of the following is our meso compound? Meso compound, that means what I said, the one part should be R and another part should be S. Yes. So let's do something, find it. If I'm thinking about this carbon, this one is 1 and which one, and this is 4. For sure we got it. Okay. Now this one and this one, which is going to get the priority? If you check the first atom, we are getting carbon. Here also the first atom is carbon, but the second atom, in this case hydrogen, and in this case the second atom is chlorine. So obviously this will get, this group will get priority and it will be 2 and this will be 3. So what we have to do? We have to move 1, 2, 3. That means we are going to get R. Yes, but H is on the vertical side, so it should be what? It should be S. I hope it is clear. Let me use another color for this next. Yes, if I'm going to see this carbon, so the one number is obviously this one. Yes, and now the two number will be given to this, isn't it? This will be given as 2. Clear बच्चे? The same way जैसे मैंने अभी find किया, and here it is 3 and here it is 4. So just move to 1, 2, 3 like this. Yani it is going S, but it will be R because H is on horizontal line. Okay. So S and R both we are going to get in the same compound. That means it will cancel each other's effect due to the internal compensation, and this should be the meso compound. Yes. Now check this one. This is 1. This one will be 2 for sure. Now I think you people are expert in this. Yes. So this one is 2 over here, and this one is 3, and this one is 4. So what will happen? This is going to move in this way, should be R, but will be S because H is on vertical, on horizontal line. Now let me use another color. If I'm going to check this carbon, the 1 is this, and 2 will get upper part will get 2. Yes, this will get the 2, and here it is 3, and this one is 4. So just move 1, 2, 3. So it is coming R, but it will be S because H is on the horizontal. Yes. So दोनों ऐसा हो गया. That means it is not going to be meso compound. ये meso नहीं होगा. Now let's do this. 1, and now quite clear. I don't think to explain again. This part is second. Yes. And this part is third, and here it is fourth. So if we move in this way, we are going to get R, but will be S because H is on horizontal. Yes. For this I'm talking about, this is 1 and the other one will be 2 for sure, and this will be 3 and here it is 4. So if I will move in this way, we are going to get S, but will be R as it is. H is on horizontal. So this is also R and S. That means this will also be the meso compound. Now check this. This is 1. This whole part is 2. नीचे 2 आ जाएगा. Here it is 3 and here it is 4. So just move 1, 2, 3. It is going to be R, but will be S as H is on horizontal side. Yes. And next example, next part if I'll do. For this it is 1 and the second part is above, and here it is third and here it is fourth. So this is going to move in this way, and it is also getting clockwise, but H is on the horizontal, so it will also be S. And these two will be the meso compound. I hope it is clear. Any doubt? Okay. Now next question. This one is given. You just find it what it will be. In this case, the carbon is, this one is for sure 1. Yes, it is going to be 1. Clear hai bachche? Now out of this and this, which one is going to get priority? I have told you that multiple bond will get the more priority. So this one will be 2 and here it will be 3. So just move 1, 2, 3. What we are going to get? We are getting S. And would it be S only? Yes, because H is on the vertical side. So it will be S only. Got it? समझ में आ गई बात? Let's move to next. This one. This is carbon number. Okay. Don't be confused. This is carbon number. It is. Okay. So now just check this carbon 2. For carbon 2, we will check. First group will be what? Which one? Fourth is for sure. ये आ गया. अब यहाँ देखो first carbon is first atom is carbon, carbon, carbon. Second atom is oxygen. In this case, if I'm coming, oxygen. Third is also oxygen, but in this case, third is H. So this will get more priority. Sorry, 1. This will be 1, isn't it? And नीचे हो गया, ये हो जाएगा 2. The lower part will be, this part will be 2. And here it will be 3. So just move 1, 2, 3. If I'm going to get the S, but H is on horizontal, so we will say reverse, and this will be R. Clear? Now come to this next point. अगर हम चलते हैं यहाँ पे आते हैं, so this is for sure O. Here it is carbon, here it is carbon, but it is oxygen. So this will be 1, isn't it? इस case में, okay. And 2. This one is carbon, this one is carbon. Next case, again the carbon, but in this next case, we are going to get this oxygen. Sorry, carbon only. This is carbon now. Okay, here carbon. Third case, if I'm going to check, we are going to get oxygen. In this case, third case also oxygen. But fourth case, it is H, and fourth case, it is oxygen. So this will get, this above group will be considered as 2. ये mark हो जाएगा 2. And this will be marked as 3. So just move 1, 2, 3. That means we are going to get S, but it will be R. Yes. Why? Because of the same. So what should be that? 2R and 3R. Carbon 2 भी R है and carbon 3 भी R है. So the answer should be 2R and 3R. Hope it is clear. Yes. चलिए. Now about this. This one is 1 carbon. One number priority, and now check, obviously this is going to be second. Yes, quite clear hai? I hope now you should be expert in this. Yes, and this is 4. So what it is? 1, 2, 3. So that means it is clockwise, but H is on the horizontal, so it will be S. Now in this case, if I'm talking about this, so this one will be 1, and the second part is obviously ऊपर वाला ही हो जाएगा, and here it is 3, and here it is 4. So this way 1, 2, 3. If I'm going, this is also R, but will be S because of horizontally placed hydrogen. So what will be the answer here? Here also both will be 2S and 3S will be 2 and carbon 2. This is the carbon 2, 1, 2. And this will be the 3. 2 and 3 both will be S. I hope it is clear. So now we have to do this next thing, that is chemical properties, and in that chemical properties SN1 and SN2 already we have done. So now it is elimination reaction left and reaction with the metal left. So we'll do in the next class. I hope you have watched the video properly and you got the concept. If still there is any doubt, please feel free to ask. And we'll meet you in next video. So till then, thank you class. Enjoy your study.